This is the solution to problem 7 from the Triangle Trig applications notes. So we're told that Cal is standing 100 feet from his bike, and then he walks 50 feet in a straight line and finds that he is now 120 feet from his bike. How far from his bike will Cal be if he walks another 50 feet in the same direction? Give your answer rounded to the nearest hundredth of a foot. So we're not given a diagram here, so we need to create our own. So I'm going to draw a line segment. I'm going to label point B where his bike is. I'm going to call the end point of that line segment A. That's where I'm going to have Cal initially be. So initially he's 100 feet from his bicycle. And then he walks 50 feet in a straight line. So we don't know exactly which way he walks. So it doesn't matter, right? These diagrams are not necessarily to scale. So he's going to walk 50 feet, I'm going to say in this direction. So I know this length is 50 feet. And at that point, we're told he's 120 feet from his bicycle. I'm going to label that point C. So if he's 120 feet from his bicycle at that point, that means segment CB is 120 feet long. So I'm going to go ahead and draw in segment CB. And I'm going to label that as 120 feet. And then we're told that Cal walks 50 feet in the same direction. So I'm going to continue along the same path that he was on before for another 50 feet. I'm going to label that point where he ends point D. And we're asked to find out how far Cal will be from his bike after he walks an extra 50 feet. So that distance is BD. So this is what we're trying to find, BD. I'm actually going to move where I wrote the 120 feet a bit and make that a little more clear. So BD is what we need to find. BC was 120. So I'm going to write that here, 120 feet. And we need to find BD, which let's just call that X for now. All right, so we see in this case we have multiple triangles that we could use, and we have to decide where to begin. So I would recommend that we begin with triangle ABC. So I'm going to highlight that for a second, because in triangle ABC we know all three sides, and from that we can find any angle. And angle A might be a good angle for us to find, because then we can move from triangle ABC to the whole outer triangle ADB, and that will help us find X. So that's kind of just a general plan. So I know that we have a side situation with triangle ABC, which means we can use the law of cosines to find angle A. So let's do that. So we are going to say, remember law of cosines, a squared is equal to b squared plus c squared minus 2bc cosine of angle A. So in this case, we have 120 squared is equal to 50 squared plus 100 squared minus 2 times b, which was 50, times 100, which is c, times cosine of A. If it helps, I can label these lengths. This one would be c, and this is little b. Side lengths opposite the vertices. And 120 is our little a. Okay, once we have that, we start entering things into our calculator. So 120 squared, if you enter that is 14,400. Is equal to 50 squared plus 100 squared turns out to be 12,500. Minus 2 times 50 times 100 is 10,000 cosine A. You will subtract 12,500 from both sides. That'll leave us with 1,900 is equal to negative 10,000 cosine A. Next, we have to divide both sides of the equation by negative 10,000 to isolate cosine A. And then we'll have cosine A is equal to negative 1,900 over 10,000. And if we, that simplifies to negative 19 over 100. So A is equal to cosine inverse of negative 19 over 100. And if you enter that into your calculator, you'll find the measure of angle A is 100.95 degrees. And I'm going to go ahead and write that value on our triangle, on our diagram. So the measure of angle A is 100.95 degrees. And now we need to find the length BD, which I labeled X in my diagram. So to keep things a little clearer here, I'm actually going to make a new diagram. And the new diagram is going to be looking at the outer triangle. So that's going to be triangle ABD. So I'm going to redraw that here. So, and then I'm going to make it a little less confusing as to all the information that we have. So I'm going to label the vertices A, D, B. We just found that the measure of angle A is 100.95 degrees. AB, we know that's 100 feet. And then AD is going to be, that's 50 feet plus 50 feet. So that will be 100 feet. And now we need to find little a, which I called X in my previous diagram. But now I'm going to call it little a because it corresponds with our laws of sines and cosines if we use it that way. So if we look at this setup, we have side, angle, side. So we have, I'm going to write that down here, we have with triangle ABD, we have side, angle, side, which means we can use law of cosines. Law of sines won't work here because we don't have an angle and the length of its opposite side. So we don't have one of those pairs. So we're going to set up law of cosines to find little a. So law of cosines would be a squared, that's what we want to know, is going to be equal to 100 squared plus 100 squared minus 2 times 100 times 100 times cosine of angle A, which was 100.95 degrees. If you enter this in your calculator, you get 100 squared plus 100 squared is 20,000 minus this 2 times 100 times 100 times cosine 100.95 turns out to be negative 3,800. So A squared is equal to 23,800. And then we take the square root of both sides and we get A is equal to 154.27 feet. So we can conclude that Cal is 154.27 feet from his bicycle.